Hello, cosmic enthusiasts. In today's video, we dive deep into one of the most fascinating discoveries by the James Webb Space Telescope, an exoplanet with a singular vast ocean covering its entire surface. Buckle up as we embark on a journey to understand what makes this exoplanet uniquely captivating and what it might tell us about the search for extraterrestrial life. Water is the essence of life, a crucial ingredient without which no known life form on Earth could survive. Our quest to understand life invariably revolves around the hunt for liquid water. Thus, the global excitement was palpable when the James Webb Space Telescope recently identified possible traces of methane and dimethyl sulfide on the distant exoplanet K2-18b. These findings suggest the potential for an oceanic world teeming with life, perhaps even on a microscopic level. However, K2-18b is a staggering 124 light-years away. With our current rocket technology, a journey there would span nearly 1,000,000 years. But imagine if we discovered a more accessible world, one enshrouded in clouds, with a temperate ocean half the size of the Atlantic Ocean. Ladies and gentlemen, it seems the James Webb Space Telescope may have just pinpointed the most promising candidate for a habitable planet beyond our solar system. Introducing LHS 1140b. Discovered in 2017, this exoplanet orbits in the habitable zone of its red dwarf star, LHS 1140. What sets this exoplanet apart? Special indeed, LHS 1140b is just 40 light-years from Earth. Initially, further observations hinted it might resemble a smaller version of Neptune, a gas giant. Yet this perception shifted dramatically last December when we aimed our state-of-the-art superstar telescope at this distant world. In collaboration with data from the Hubble and Spitzer telescopes, the James Webb Space Telescope has painted a strikingly different picture of LHS 1140b. This exoplanet now emerges as a prime candidate within its star's habitable zone, potentially boasting both an atmosphere and a vast ocean of liquid water. The latest revelations are indeed thrilling. LHS 1140b may possess a nitrogen-rich atmosphere, indicative of retaining a substantial, stable atmosphere conducive to liquid water. But the intrigue doesn't stop there. According to recent analyses, between 10% and 20% of the exoplanet's mass could be liquid water. This suggests a mesmerizing possibility. LHS 1140b might resemble a gigantic snowball, uniquely orbiting its star so that one hemisphere perpetually faces it, similar to our moon's synchronous rotation with Earth. Imagine, if you will, the hemisphere facing the star continuously bathed in heat, gradually melting portions of this colossal snowball to form a sprawling ocean. This scenario sketches a vivid portrait of a world both alien and familiar, where life might just find a way to thrive. Many of you might think that LHS 1140b is just another super-Earth, similar to countless others we've discovered over the past decade. However, it stands apart in significant ways. Take, for example, the TRAPPIST-1 star system, known for its 7 planets and a configuration somewhat reminiscent of our own solar system. Yet, when the James Webb Space Telescope focused on TRAPPIST-1, it uncovered a highly active central star that could distort observations and mislead us about habitability. This is not the case with LHS 1140b. Its host star, LHS 1140, is notably calmer and less active, which simplifies the task of analyzing the exoplanet's atmosphere without interference from stellar activity such as star spots. Ryan McDonald from NASA, who has been pivotal in studying the exoplanet's atmosphere, highlights that this quieter stellar environment makes LHS 1140b a unique case. According to current models, if LHS 1140b possesses an Earth-like atmosphere, it could be characterized as a snowball planet, featuring a massive bullseye ocean some 4,000 kilometers across. McDonald further suggests that the ocean's surface temperature might hover around a pleasant 20 degrees. So, what's the next step? The research team has requested additional transit and eclipse measurements using the Webb telescope. These forthcoming observations aim to target specific signals that could confirm the presence of carbon, potentially underscoring LHS 1140b's similarity to Earth. This isn't just another super-Earth. It's a leading candidate for habitability outside our solar system. Due to LHS 1140b's limited visibility, the Webb telescope can only observe it a maximum of 8 times per year. This means astronomers will need several years of observations to detect carbon dioxide and confirm the presence of liquid water on the planet's surface. Nonetheless, this marks an incredibly promising beginning. To further our quest to find life beyond Earth, it's crucial to validate Webb's capability to accurately analyze exoplanetary atmospheres. To address this critical question, scientists have embarked on an inventive experiment. They're testing whether the space telescope can detect signs of intelligent life on the one planet where we already know it exists: Earth. In this innovative study, researchers analyzed a spectrum of Earth's atmosphere. They deliberately degraded the quality of the data to mimic how it would look to an observer many light years away. Using a computer model that emulated the James Webb Space Telescope's sensor capabilities, the team scrutinized whether the spacecraft could still identify key biosignatures and technosignatures. These include methane and oxygen, which are indicative of biological life, as well as nitrogen. This experiment not only tests the telescope's precision, but also deepens our understanding of how to interpret signs of life from distant worlds. Dioxide and chlorofluorocarbons, markers associated with human activity, were also included in the study. While the findings await peer review, they hint that the James Webb Space Telescope, JWST, might be capable of identifying all significant markers of both non-intelligent and intelligent life in Earth's atmosphere. The researchers noted that the quality of the degraded dataset is akin to JWST's observations of planets within the TRAPPIST-1 system, some 40 light-years from Earth. This promising result suggests that the telescope could detect signs of life, or even advanced civilizations, on exoplanets within a 40 light-year radius of Earth. More ambitiously, the team speculates that JWST's reach could extend to spotting extraterrestrial life signs up to 50 light-years away. Presently, about 20 exoplanets have been officially identified within this 50 light-year radius. However, experts believe there could be as many as 4,000 exoplanets within JWST's observational range, considering the number of stars suspected in this segment of space. While this capability opens thrilling possibilities, it's important to note that the ability to detect these signatures does not guarantee the definitive detection of life on other planets. The path ahead involves rigorous observation and analysis, setting the stage for one of the most exciting chapters in the search for extraterrestrial life. Interpreting biosignatures and technosignatures on alien worlds presents unique challenges, as noted by researchers. A planet harboring life might not only operate under vastly different conditions, but could also develop technologies beyond our current understanding. Such differences mean that life signatures might not be immediately recognizable to us. What are your thoughts? Do you think the Webb telescope will soon find concrete evidence of life beyond Earth? Meanwhile, skepticism remains among some scientists regarding the presence of atmospheres on rocky planets observed by the JWST, especially those orbiting end-dwarf stars. These stars, though small and dim, making them easier targets for JWST, often emit intense bursts of radiation that could strip away planetary atmospheres. This has led to doubts about whether rocky planets in such harsh environments can maintain their atmospheres. For instance, Webb's observations of LHS 3844b, a super-Earth orbiting an M-dwarf star, suggest that the planet is likely just a bare rock. Similar observations of TRAPPIST-1b and TRAPPIST-1c, both orbiting the M-dwarf star TRAPPIST-1, also indicate that they, too, are likely devoid of atmospheres. The quest continues, however, as scientists relentlessly seek signs of habitable conditions and life elsewhere in the cosmos. Astronomers at the Paris Observatory have raised the possibility that these planets may harbor extremely thin atmospheres. Continued observations with the James Webb Telescope will be crucial in providing clarity. As JWST delves deeper into the study of rocky planets, both with and without atmospheres, our understanding of what I like to call the cosmic shoreline, the delicate boundary between habitable and inhospitable worlds, will be significantly tested and refined. The James Webb Space Telescope, with its unparalleled observational capabilities, recently identified an exoplanet that is unlike any other we've known. This distant world, located several light-years away from Earth, is covered entirely by one massive ocean. Today, we explore the initial findings and what led astronomers to this breathtaking discovery. What does an exoplanet entirely covered by an ocean look like? With no land in sight, this planet challenges our understanding of what makes a planet habitable. Its surface, temperature, and atmospheric conditions are driven by this vast ocean, creating dynamics that are drastically different from the terrestrial environments we are familiar with. The existence of a global ocean suggests possibilities for life that are as exciting as they are speculative. This segment delves into the potential biosignatures that scientists are on the hunt for, and how this exoplanet could serve as a natural laboratory for studying extraterrestrial marine biology. This discovery wouldn't have been possible without the advanced technology aboard the James Webb Space Telescope. We'll take a closer look at the instruments that made this observation possible and how they're reshaping our understanding of the cosmos. Looking ahead, what does the discovery of an ocean-covered exoplanet mean for future missions and studies? This segment explores upcoming missions, potential collaborations, and the long-term implications for both astronomy and astrobiology. Let's compare this exoplanet's single ocean to the diverse marine environments of Earth. How does an ocean with no land boundaries differ in terms of currents, ecosystem dynamics, and climate? This analysis helps us appreciate the complexity and balance of our own planet's oceans and speculate about the alien conditions on a water world. A planet covered entirely by an ocean could experience extreme weather patterns unlike anything on Earth. Imagine giant storms, endless hurricanes, and peculiar cloud formations. We will explore how these conditions could form and what they imply about the planet's climate system. The composition of the ocean on this exoplanet, particularly its salinity and the presence of other chemical elements, plays a crucial role in its habitability. This segment examines what we know about the water chemistry and how it affects theories regarding life beyond Earth. With one ocean-covered exoplanet found, are there more to be discovered? We'll discuss the methods astronomers use to detect similar planets and the significance of finding more worlds dominated by oceans in our galaxy. Exploring an all-ocean exoplanet presents unique challenges. From the technical difficulties in landing a probe on a liquid surface to the communications barrier posed by a deep water environment, this segment covers the obstacles researchers face. What does the discovery of such a unique planet tell us about the nature of the universe and our place within it? This philosophical inquiry explores the broader implications of finding such a world and how it challenges our Earth-centric view of life and the cosmos. Throughout human history, water has been a source of myth and inspiration. This segment delves into how the idea of a water world sparks the imagination and influences cultural narratives about distant, mysterious planets. How does the gravitational force of a planet entirely covered by water affect its ocean tides, wave dynamics, and potentially even its geophysical processes? This analysis helps us understand the physical interactions on such a unique planetary body. The type of star this planet orbits plays a critical role in its climate and environmental conditions. We'll examine how the planet's sun affects its oceanic temperatures and ecological potential, comparing it to the sun's impact on Earth. If life exists on this ocean planet, it might be found not on the surface but below it. This segment explores the concept of subsurface life, drawing parallels to Earth's deep-sea organisms and the unique adaptations required to survive in such extreme conditions. Advanced imaging techniques allow astronomers to study distant planets in detail. We'll look at how these techniques are used to gather data about the planet's atmosphere, surface, and potential signs of life. Does this ocean-covered planet have moons? And how might they affect its ocean dynamics? This segment explores the gravitational interplay between the planet and any natural satellites, affecting tides and possibly even biological cycles. An entire planet covered in water would have a unique water cycle. We will explore how evaporation, condensation, and precipitation might occur on such a world and the implications for its climate and weather systems. Cosmic rays and other forms of radiation can have significant effects on a planet's atmosphere and potential habitability. This segment assesses the protection offered by the planet's atmosphere and the possible consequences of its exposure to cosmic rays. On Earth, hydrothermal vents support rich, diverse ecosystems. Could similar systems exist on this all-ocean exoplanet? This segment explores the possibility of life-sustaining hydrothermal vents on the ocean floor, considering how such environments could be hotspots for alien biology. Navigating and mapping an entire oceanic planet presents unprecedented challenges. How can scientists develop strategies to map vast, unbroken expanses of water from space? We'll discuss the potential technologies and methodologies that could be used for such an endeavor. The pressure on a planet covered entirely by an ocean would vary greatly from surface to depths possibly much greater than Earth's oceans. This segment delves into how extreme pressures could affect the physical and chemical processes on the planet, influencing everything from its climate to potential life forms. The discovery of an ocean-covered exoplanet impacts not just science, but also our culture. This segment examines how such discoveries influence our literature, art, and collective imagination, inspiring a new generation of storytellers and thinkers. What could the discovery of valuable resources on an ocean planet mean for future space exploration? This segment discusses the economic implications, including the potential for interstellar resource extraction and its ethical, legal, and logistical challenges. How is this discovery being used to educate and inspire the public about space exploration? We'll look at educational programs, public outreach initiatives, and how they help to foster a deeper interest in and understanding of extraterrestrial environments. The discovery of such a unique planet encourages global cooperation in space exploration. This segment highlights the international efforts to study this ocean planet, showcasing how collaboration across borders enriches our scientific endeavors. Scientists use theoretical models to understand planets like this one. We will explore the models that describe ocean-covered planets, discussing how they help predict conditions on such worlds and guide future observational strategies. What futuristic technologies might we develop to explore ocean-covered exoplanets? This segment imagines the advanced submarines, remote sensors, and other technologies that could one day make remote oceanic exploration feasible. How might life evolve on a planet completely covered by an ocean? This segment explores various evolutionary scenarios, considering the adaptations life forms might need to survive and thrive in an aquatic environment without land-based resources. Isolation can lead to unique biodiversity. Here we explore how the isolation of an oceanic exoplanet could lead to the development of highly specialized marine species, similar to Earth's remote island ecosystems, but on a planetary scale. Communicating through vast oceanic depths presents significant challenges. This segment discusses potential methods for future probes to communicate through deep water, examining both current technologies and speculative advances. Artists have long been inspired by the unknown. This segment looks at how contemporary artists interpret the concept of an ocean-covered planet, using their work to visualize and understand this alien world through paintings, digital art, and installations. The discovery of an entirely oceanic exoplanet also impacts our psychological understanding of the universe. We'll discuss how such discoveries shift our existential perspective and influence our sense of cosmic loneliness or connectedness. Imagining human presence on such a planet, what would structures look like? This segment explores architectural concepts designed for survival and exploration in a completely aquatic environment, including floating bases and submerged habitats. As we contemplate exploring and possibly utilizing resources from ocean planets, what legal frameworks will govern these activities? This segment addresses the international treaties and agreements that might extend to the exploitation of extraterrestrial marine resources. The increasing role of private companies in space exploration could extend to ocean planets. We discuss how private enterprises might contribute to the exploration and study of ocean-covered exoplanets and the potential for commercial ventures. Exploring an ocean planet raises significant ethical questions, especially concerning potential life forms. Welcome to Blasovia Science TV, where we take you on an exhilarating journey through the cosmos and unravel the mysteries of science. We are excited to offer you the opportunity to become a valued member of our ever-growing community of cosmic enthusiasts and knowledge seekers. Exclusive access to cosmic content. As a member of Blasovia Science TV, you will gain exclusive access to a treasure trove of cosmic content, including documentaries, interviews with leading scientists, space missions updates, and awe-inspiring visualizations of the universe. Live Q&A sessions with experts. Your membership will grant you the chance to participate in live Q&A sessions with renowned scientists, astronomers, and space explorers. Get your burning questions answered by those who push the boundaries of human knowledge. Embark on a journey that spans the cosmos and join us in unraveling the secrets of the universe. Become a Blasovia Science TV member today, and together we will reach for the stars. Thanks for watching. Subscribe, like, and share. Don't forget to leave your comments.